Picture this. It's a completely ordinary night. Somewhere on Earth, a rocket lifts off, does its job perfectly, delivers its payload exactly where it needs to go, and then it's forgotten. Nobody thinks about it again. No headlines. No follow-up. It just becomes another piece of hardware floating silently through the vacuum of space, tumbling end over end, with absolutely nothing left to do and nowhere it's supposed to be. And then, months or years later, it does something nobody planned for. It slams into the moon at thousands of miles an hour, punches a brand new hole into a surface that hasn't changed in millions of years, and gets caught red-handed by a spacecraft that just happened to be looking in exactly the right place at exactly the right time. That's not a movie plot. That's exactly what happened just weeks ago, and almost nobody outside the space community even noticed until NASA released the photos. So let's talk about what actually happened, why it happened, why NASA is genuinely excited about it even though it was technically an accident, and what it tells us about a problem that's only going to get bigger the more we launch into space. Here's the short version before we get into the details. On the 5th of August, a discarded upper stage from a SpaceX Falcon rocket crashed into the moon. It wasn't supposed to happen that way. It wasn't a mission, it wasn't planned. It was leftover hardware, essentially space junk, that had been drifting for who knows how long until gravity finally pulled it down onto the lunar surface. NASA's Lunar Reconnaissance Orbiter, a spacecraft that has been quietly circling the moon for over a decade now, happened to photograph the exact spot where it happened, and what it found is a fresh crater roughly 60 feet wide and about 10 feet deep, complete with streaks of bright and dark debris blasted out in every direction like a starburst. Now, on the surface, this might sound like a minor story. A rocket part hits the moon, big deal, right? The moon has been getting hit by things for over 4 billion years. It's basically the most cratered object in our part of the solar system. What's one more hole in the ground? But stick with me here, because there's a lot more going on underneath this story than you'd think. This event touches on orbital mechanics, on how we track or fail to track objects in deep space, on a growing junkyard problem that most people have never even considered, on what scientists can actually learn from an accidental impact, and on questions about responsibility that are going to matter more and more as private companies like SpaceX keep sending more and more hardware past Earth's orbit. So let's start from the beginning. What is this thing that crashed into the moon, and how did it even get there in the first place? A Falcon rocket, like most orbital rockets, isn't a single piece. It's built in stages. The first stage does the heavy lifting right off the launch pad, burning through most of its fuel to get the rocket up and moving fast enough to escape most of the atmosphere. Once that job is done, the first stage separates and, in SpaceX's case, often lands itself back on Earth or on a floating drone ship, which is part of what made SpaceX famous in the first place, the whole reusable rocket thing. But then there's the second stage, sometimes called the upper stage. This is the part that takes over once the rocket is already high up and moving fast. Its job is to carry the payload, whether that's a satellite, a spacecraft, or some other piece of cargo, the rest of the way to its intended orbit or trajectory. Once the upper stage finishes its burn and releases its payload, it doesn't have a job anymore. And here's the thing that a lot of people don't realize. Unlike the first stage, the upper stage usually doesn't come back down to Earth in a controlled way, at least not for missions heading toward deep space or high orbits. Sometimes it's deliberately deorbited to burn up in Earth's atmosphere. Sometimes it's sent on a trajectory that takes it far away from Earth entirely, out into what's essentially a slow, aimless drift through space. For a lot of missions that go beyond low Earth orbit, especially ones heading toward the moon or beyond, that upper stage ends up in what's sometimes called a heliocentric orbit or some other long looping path that isn't precisely controlled. It's not being steered. Nobody's driving it anymore. It's just coasting, subject to the pull of the sun, the Earth, and the moon, like a marble rolling around in a bowl with multiple different gravity wells tugging at it from different directions. And when you leave something floating around like that for long enough, especially in the neighborhood of the Earth-Moon system, the math eventually catches up with it. Gravity doesn't forget about anything. Sooner or later, an object like this either gets flung out into deeper space, settles into some kind of stable orbit, or gets pulled down onto a nearby massive body. In this case, that massive body was the moon. This isn't the first time this has happened, by the way, and it almost certainly won't be the last. There have been previous cases of old rocket bodies, some from decades ago, being tracked as they drift through cislunar space, which is just a fancy term for the region between the Earth and the moon. Astronomers have occasionally spotted mystery objects out there. initially unsure whether they're asteroids or leftover human hardware, only to later confirm they're old rocket stages that have been quietly orbiting for years. It's honestly a little eerie when you think about it. There's essentially a slow-motion junkyard drifting around out there, pieces of our own space program, untracked, unmonitored in real time, occasionally showing up again when we least expect it. So when this particular Falcon upper stage finally succumbed to gravity and came down on the moon, it wasn't some freak one-in-a-billion event. It was, in a strange way, almost inevitable. It's just physics playing out over a long enough timescale. What made this case interesting wasn't the crash itself, honestly. What made it interesting is that NASA was actually watching the moon closely enough, and with the right equipment, to catch the aftermath in incredible detail. That equipment is the Lunar Reconnaissance Orbiter, or LRO for short, and it deserves its own mention here because this spacecraft is honestly one of the unsung workhorses of modern lunar science. LRO has been orbiting the moon since 2009. That's well over a decade of continuous operation, circling roughly 50 kilometers above the lunar surface, snapping incredibly high-resolution images of practically every square inch of the moon over and over again. Its main camera system is sensitive enough to spot individual boulders, footprints from the Apollo missions, and yes, fresh impact craters, sometimes within days or weeks of them forming. What LRO does that's so useful in cases like this is something called repeat imaging. Because it orbits the moon again and again, taking pictures of the same regions over time, scientists can compare an image from one pass to an image from a previous pass and spot differences. If a crater shows up in a spot that was crater-free just months earlier, that's basically an unmistakable sign that something hit the surface recently, geologically speaking. In this case, NASA compared before and after images and confirmed that yes, there is a brand new hole in the ground exactly where the Falcon upper stage would have been expected to hit based on tracking data. And this is where the story gets genuinely cool from a science perspective, because LRO didn't just take one picture and call it a day. According to NASA's own descriptions, the spacecraft imaged the crash site from multiple different viewing angles and under different lighting conditions, meaning different sun angles hitting the surface at different times. Why does that matter? Because craters and other surface features on the moon can look completely different depending on how the sunlight is hitting them. Low sun angles create long, dramatic shadows that make even small bumps and dips in the terrain incredibly obvious, almost like a topographic map rendered in light and dark. High sun angles, on the other hand, wash out those shadows but reveal differences in surface brightness, since different materials reflect sunlight differently. By imaging the same spot under multiple lighting conditions, scientists got a much richer picture, pun fully intended, of what actually happened at the impact site. The crater itself, according to the measurements NASA released, is about 18 meters wide, which, if you want a familiar comparison, is roughly the length of 2 school buses parked end to end, or about the width of a professional swimming pool used in the Olympics. It's about 3 meters deep, meaning if you somehow fell into it, you'd be in well over your head, easily deep enough to swallow a standard 2-story building's height in reverse. But the crater itself is only part of the story. What really caught scientists' attention, and honestly what makes for the most visually striking part of the photos, are the streaks radiating outward from the impact point. When something slams into the lunar surface at extremely high velocity, and we're talking speeds that could be several kilometers per second depending on the specific trajectory, the force of that impact doesn't just dig a hole. It violently ejects material outward in every direction, kind of like when you drop a rock into thick mud and watch the splash pattern spread out from the point of contact, except here the mud is billions of years of lunar regolith, the fine, powdery, sometimes glassy soil that covers the moon's surface, and the splash happens almost instantaneously and travels for a considerable distance before settling back down. Some of that ejected material appeared as bright streaks in the images, and some appeared as dark streaks, which is actually a really telling detail for scientists studying the moon's surface composition. The brightness or darkness of ejected material can indicate differences in how fresh or weathered that material is. The moon's surface, over billions of years of exposure to solar radiation, micrometeorite bombardment, and constant exposure to the vacuum of space, undergoes a process scientists call space weathering. This process gradually darkens and alters the appearance of exposed lunar material. So when an impact suddenly excavates fresh material from beneath that weathered top layer and throws it out onto the surface, it can appear noticeably brighter than its surroundings, at least for a while, until it too begins to weather and darken over time. This is honestly one of the more fascinating aspects of accidental impacts like this one. Because scientists suddenly have a natural experiment handed to them. They know almost exactly when the impact happened. They know roughly what hit the surface and at what approximate velocity. And now they get to study fresh, never-before exposed material that was previously buried beneath the moon's weathered top layer, material that essentially got dug up for free by a piece of space junk that wasn't even supposed to be there. It's a bit like an archaeologist who stumbles across a dig site because a truck accidentally crashed through a fence and exposed an ancient wall nobody knew was there. The circumstances weren't planned, and honestly they weren't ideal, but the scientific opportunity that results from it is real and valuable. Now, let's talk about SpaceX's role in all of this, because this part of the story raises some genuinely interesting questions about responsibility in the modern space industry. According to reporting on the incident, SpaceX has described the crash as an accident. And to be fair, in a very literal sense, that's true. Nobody at SpaceX sat down, calculated a trajectory, and said, let's aim this upper stage at the moon. That's not how any of this works. The upper stage was released after completing its mission, and its subsequent drift through cislunar space, eventually resulting in a lunar impact months or years later, wasn't the result of a deliberate targeting decision. But here's the more complicated question that this event raises, and it's a question the entire space industry has been wrestling with more and more as launch rates increase year after year. Even if an individual impact like this wasn't intentional, is it acceptable? From a broader policy and environmental stewardship perspective, for companies to simply release upper stages into uncontrolled trajectories without a clear plan for where they'll eventually end up. This isn't really a SpaceX-specific issue, to be clear. It's an industry-wide pattern that's been happening since the very beginning of the space age. Rocket bodies from multiple countries and multiple companies have ended up in uncontrolled trajectories over the decades, some burning up in Earth's atmosphere, some ending up in long-term stable or semi-stable orbits, and yes, some eventually colliding with the moon or other bodies. There was actually a fairly famous earlier case, a rocket body believed to have originated from a Chinese mission, that was tracked for years by amateur and professional astronomers alike as it drifted through cislunar space, with predictions of exactly when and where it would eventually hit the moon. When it finally did impact, scientists were ready and watching, much like they seemingly caught this SpaceX case as well, whether through careful tracking or fortunate timing with LRO's imaging schedule. The fact that we're now seeing multiple examples of this kind of thing, tracked, predicted, and photographed after the fact, tells you something important. Space is getting crowded, or at least the near-Earth and cislunar environment is getting crowded, and the amount of leftover hardware drifting around out there without active control is only going to increase as more countries and more private companies launch more missions. Let's zoom out for a second and talk about why this matters beyond just being a cool photo of a crater. First, there's the scientific value, which we've already touched on but deserves more attention. Every unplanned impact on the moon, when it's well documented like this one, gives scientists a rare kind of controlled experiment. They know the approximate mass and velocity of the impactor. They know the exact timing, and they get before and after imagery of the exact same location. This is incredibly valuable data for understanding impact mechanics, something that's actually really hard to study otherwise, because we obviously can't just go around slamming things into the moon on purpose very often. And even when missions do intentionally target the lunar surface for scientific impacts, those are expensive, rare, and carefully planned events. In fact, NASA has done deliberate impact experiments before specifically because of how valuable this kind of data is. There was a mission a number of years back that intentionally crashed a spent rocket stage into a permanently shadowed crater near the moon's south pole, specifically to kick up a plume of material that could then be analyzed for the presence of water ice. That mission required enormous planning, precise targeting, and a whole suite of instruments positioned to observe and analyze the resulting plume in real time. The fact that an accidental impact like this SpaceX case gives scientists some of that same kind of data, essentially for free, without any of the mission planning or cost, is a genuine silver lining to an otherwise unplanned event. Second, there's the tracking and space situational awareness angle, which is honestly the part of this story that deserves way more public attention than it usually gets. The fact that a piece of hardware can drift around unmonitored for an extended period, and then suddenly show up as a fresh crater on the moon says something important about the limits of our current tracking capabilities. We are reasonably good at tracking large objects in low Earth orbit, things like active satellites and larger pieces of debris close to home, largely because there's a strong incentive to do so given how crowded that region has become and how much damage a collision could cause to expensive, functioning satellites. But once you get further out, into the region between Earth and the Moon, or beyond, tracking becomes much harder and much less consistent. Objects out there are smaller relative to the vast distances involved. They're harder to observe with ground-based telescopes, and honestly, there hasn't historically been as strong an economic or safety incentive to track them closely, since the odds of them hitting anything we actually care about, like an active spacecraft, have been relatively low. That calculus is starting to change, though, and this is honestly one of the more important underlying threads in this whole story. As more and more missions head toward the moon, whether that's crewed missions under NASA's Artemis program, robotic landers from multiple countries, private companies building lunar infrastructure, or scientific missions targeting the lunar surface and orbit, the amount of real estate around the moon that we actually care about is growing rapidly. Uncontrolled debris drifting through that same region, historically a non-issue because there was so little else out there to hit, is becoming a more relevant safety concern. Think about it this way. If a piece of drifting space junk crashes into an empty patch of lunar surface, like what happened here, it's mostly just an interesting science opportunity. Nobody gets hurt, nothing valuable gets damaged, and scientists actually benefit from the natural experiment it creates. But if that same kind of uncontrolled object were to instead collide with an active lunar orbiter, a crewed spacecraft, or a surface habitat sometime in the future as lunar activity increases, the consequences could be a lot more serious. The pattern we're seeing now, occasional uncontrolled impacts that we can only really confirm after the fact through orbital imaging, is a sign that our current approach to tracking and managing this kind of debris probably needs to evolve as lunar activity ramps up. Third, and this is maybe the broader cultural point worth sitting with for a moment, this event is a small but pretty vivid reminder of just how much human activity has already reached beyond Earth, and how the consequences of that activity, even the unintended ones, are now literally visible on the surface of another world. The moon has been getting hit by natural impactors for billions of years. That's true. And in the grand cosmic scheme of things, one more small crater from a piece of space debris is a drop in the bucket compared to the ancient, massive impact basins that shaped so much of the moon's surface long before humans existed. But there's something genuinely different about a crater that we know, with high confidence, was created by a piece of technology that we built and launched with our own hands, drifting through space for who knows how long before finally coming to rest, quite literally, as a permanent mark on the face of the moon. It's the kind of thing that decades or centuries from now could be studied not just as a geological feature but as a historical marker, evidence of a particular era when humanity was launching things into space faster than we were tracking where they ultimately ended up. Let's talk a bit more about what actually happens, physically, during an impact like this, because I think understanding the mechanics makes the whole thing even more impressive, or at least easier to visualize. When an object, like a spent rocket stage, which can weigh anywhere from hundreds to well over 1,000 kilograms depending on the specific vehicle, and how much fuel or material remains in it, hits the lunar surface, it's typically moving at a velocity of several kilometers per second. To put that in perspective, that's several times faster than a typical bullet fired from a rifle. At those speeds, the kinetic energy involved is absolutely enormous, and when that energy gets released almost instantaneously upon impact, it doesn't behave like a normal collision you'd see on Earth. It behaves more like an explosion. The impacting object doesn't just punch a hole the size of itself into the ground. Instead, the extreme pressures generated at the moment of impact essentially vaporize or pulverize both the impactor and a significant volume of the surrounding lunar material almost instantly. That energy then propagates outward and downward in a shock wave, compressing and displacing material, before rebounding and throwing debris outward and upward in that classic radial pattern you often see around craters, on the moon and elsewhere. This is why the resulting crater, at 18 meters wide, is significantly larger than the physical size of the rocket stage that caused it. The crater isn't a direct impression of the object's shape and size. It's the result of that violent release of kinetic energy interacting with the lunar surface material, following the physics of high-velocity impact cratering that scientists have studied extensively, both through laboratory experiments here on Earth and through observations of craters on the Moon, Mars, and other bodies throughout the solar system. The debris that gets thrown outward during this process, what scientists often call ejecta, doesn't just fall straight back down near the crater rim either. Because the Moon has essentially no atmosphere to slow things down through air resistance, ejected material can travel remarkably far from the point of impact before finally settling back onto the surface under the influence of the Moon's relatively weak gravity, which is only about 1/6 of Earth's. This is part of why the streak patterns visible in the LRO images extend outward across such a wide area relative to the size of the crater itself. On Earth, an impact of similar energy would likely produce a much more contained debris pattern because our thick atmosphere would slow down and redirect a lot of that ejected material. On the airless Moon, there's nothing to stop it from traveling in long, relatively straight trajectories before landing. This whole process, from the moment of impact to the final settling of ejected debris, happens in a matter of seconds, and yet the resulting features, the crater and its surrounding streak pattern, will likely remain visible and largely unchanged for an extremely long time, potentially millions of years, since the Moon lacks the erosional processes we're used to on Earth. Things like wind, rain, and flowing water that gradually wear down and reshape our planet's surface over time. Barring another direct impact on that exact spot, or the extremely slow, gradual effects of space weathering and micrometeorite bombardment, this crater and its streak pattern are essentially permanent additions to the lunar landscape. Now, let's step back and put this specific event into a broader context of other things that have hit the Moon, both accidentally and on purpose, because it turns out humanity has quite a history in this department, and it goes back much further than you might expect. The very first human-made object to ever reach the Moon was a Soviet spacecraft that deliberately impacted the lunar surface back in 1959 as part of the early space race between the United States and the Soviet Union. That mission was intentional, designed specifically to demonstrate that a human-made object could actually reach another world, which at the time was an absolutely enormous technological and symbolic achievement. Since then, there have been numerous deliberate lunar impacts, ranging from early test missions to more recent scientifically motivated impacts, like the one designed to search for water ice near the lunar South Pole that we mentioned earlier. But alongside all of those deliberate, planned impacts, there's also been this quieter, less publicized history of accidental and uncontrolled impacts, pieces of hardware from various missions over the decades that, much like this SpaceX Falcon upper stage, ended up drifting through space after completing their primary mission and eventually succumbed to the Moon's gravity. Some of these have been well documented and tracked in advance, allowing scientists to prepare observation campaigns similar to what seems to have happened with LRO in this case. Others have likely gone completely unnoticed, especially in the earlier decades of the space age, when tracking capabilities were far more limited than they are today, and when there was no spacecraft like LRO constantly re-imaging the lunar surface to catch these kinds of changes. It's actually a little humbling to think about how many small, unrecorded impacts might have happened on the Moon over the past several decades of the space age that we simply never noticed, because nobody was looking at the right spot at the right time with the right equipment. The fact that we caught this one in such impressive detail, with multiple lighting angles and clear before and after comparisons, is really a testament to just how far our lunar observation capabilities have come, largely thanks to missions like LRO that have been diligently mapping and remapping the Moon for over 15 years now. Let's also talk about why this particular moment in space history makes stories like this one increasingly likely to happen, and increasingly likely to be caught when they do. We're currently in the middle of what a lot of people in the space industry have started calling a new era of lunar activity, sometimes even referred to as a new race to the Moon, except this time it's not just two superpowers competing against each other. It's multiple countries, multiple space agencies, and a growing number of private companies, all launching missions toward the Moon for a whole range of reasons, from scientific research to resource exploration to laying the groundwork for eventual permanent human presence. NASA's Artemis program is aiming to return humans to the lunar surface, something that hasn't happened since the final Apollo mission over 5 decades ago. Alongside that crewed program, there's an increasing number of robotic landers and orbiters being launched by various countries and private companies. Some successful, some not, all adding to the overall traffic heading toward the moon. Commercial companies are launching landers as part of programs designed to deliver scientific payloads to the lunar surface on behalf of NASA and other customers. Other countries have their own independent lunar exploration programs, actively sending landers, rovers, and orbiters. All of this activity means more launches, and more launches inevitably means more of those upper stages and other pieces of hardware being released into space after completing their primary missions. Not all of those pieces of hardware are going to be perfectly disposed of through controlled reentry or precisely managed trajectories. Some are always going to end up drifting, at least for a while, subject to the same gravitational tugging that eventually pulled this particular Falcon upper stage down onto the lunar surface. Given that trend, it's honestly reasonable to expect that we're going to see more stories like this one in the coming years, not fewer. More uncontrolled impacts, more craters showing up unexpectedly in LRO imagery, more moments where scientists have to piece together after the fact exactly what hit the moon and why. And this raises a legitimate question worth thinking about. At what point does this pattern of accidental impacts stop being a quirky, interesting side story and start becoming enough of a pattern that the space industry and regulatory bodies feel pressure to establish clearer standards for how upper stages and other spent hardware should be disposed of, especially for any mission whose trajectory takes it anywhere near the moon? There isn't a clean, definitive answer to that question yet. Space law and space policy in general has historically struggled to keep pace with the actual rate of technological and commercial development in the space industry. The foundational treaties governing outer space activity were largely written decades ago, during an era when the number of active spacefaring entities was tiny compared to today, and long before commercial companies were launching rockets at anywhere near the frequency we see now. Updating that framework to address newer issues, like the long-term disposal of upper stages that end up drifting through cislunar space, is the kind of slow, complicated, multinational process that tends to lag well behind the pace of actual technological development. In the meantime, events like this SpaceX Falcon upper stage impact serve as useful, concrete case studies, small but real examples that space agencies, policymakers, and the public can point to when discussing why this issue deserves more serious attention going forward. Let's bring this back to something a little more grounded and tangible for a moment, because it's easy to get lost in the bigger picture policy discussion and lose sight of just how genuinely cool this specific event is from a pure science and exploration standpoint. Think about the sequence of events here. A rocket launches from Earth, does exactly what it was designed to do, delivers its payload successfully, and then its job is done. That upper stage then begins an entirely unplanned, unguided journey through space, potentially for months or even years, tumbling silently through the vacuum, completely disconnected from any kind of active control or communication. Nobody on the ground is steering it. Nobody is checking in on it regularly. It's essentially a piece of abandoned technology, adrift in the depths of space, subject entirely to the whims of gravity. And then, after all that time drifting, it finally reaches the end of its journey, not through any deliberate plan, but simply because the accumulated gravitational pull of the Earth and Moon system finally brought it down. It slams into the lunar surface at incredible speed, releasing a burst of energy that excavates a crater and throws material across the surrounding landscape in a matter of seconds. And then, almost as if the universe wanted to make sure we didn't miss it, a spacecraft that has been faithfully orbiting the moon for over a decade happens to pass over that exact spot at the right time, under the right lighting conditions, and captures the whole story written into the lunar surface. There's something almost poetic about that sequence of events, honestly. A piece of human technology, built for one specific purpose, completing an entirely different and unplanned journey across the emptiness of space, before finally leaving a permanent mark on the surface of another world, all of it quietly documented by another piece of human technology that just happened to be in the right place at the right time. It's also worth pointing out just how much this kind of story depends on the quiet, unglamorous, long-term work of missions like LRO. This isn't a flashy new mission that just launched with a lot of fanfare. It's a spacecraft that's been steadily doing its job, orbit after orbit, year after year, for well over a decade now, patiently mapping and remapping the same landscape over and over again. It's the kind of long-term scientific infrastructure that doesn't always make headlines on its own, but that turns out to be absolutely essential when something unexpected happens, like an uncontrolled rocket stage suddenly showing up as a fresh crater where there wasn't one before, Without a spacecraft like LRO consistently monitoring the lunar surface, this event might have gone completely unnoticed. Just another small, unrecorded impact added to the long, largely undocumented list of things that have quietly hit the moon over the decades since the start of the space age. Instead, because of that consistent monitoring, we got detailed imagery, precise measurements of the crater's size, clear evidence of the ejecta pattern, and a genuinely valuable data point for scientists studying impact processes and lunar surface composition. Now let's think a little bit about what comes next, both for this specific crater and for the broader issue it represents. For the crater itself, scientists will likely continue studying the available imagery for some time, extracting whatever useful data they can about impact mechanics, the composition of the freshly exposed material, and how the appearance of the site changes as space weathering gradually begins to darken and alter the freshly exposed material over the coming months and years. It's the kind of slow, incremental scientific process that won't produce a single, dramatic headline-grabbing discovery, but that will likely contribute, in small but meaningful ways, to our broader understanding of impact cratering and the composition of the lunar subsurface in that particular region. For the broader issue of uncontrolled space debris and its potential impact on the growing amount of activity happening around the moon, this event will likely be cited, alongside similar previous cases, as part of an ongoing conversation about how the space industry and the various regulatory and policy bodies overseeing it should approach the disposal of spent hardware going forward. As lunar activity continues to ramp up over the coming years, with more crewed missions, more robotic landers, and more long-term infrastructure being planned for both the lunar surface and lunar orbit, the tolerance for unpredictable, uncontrolled impacts is likely to decrease. What's a fascinating, low-stakes science opportunity today, when there's relatively little valuable infrastructure around the moon that could be accidentally hit, becomes a more serious safety concern in a future where the moon is home to active bases, regular crewed missions, and a much busier orbital environment. It's worth remembering, too, that this specific event, as interesting as it is really just one small data point in a much larger ongoing story about humanity's expanding footprint beyond Earth. Every year, more rockets launch. Every year, more satellites, landers, orbiters, and other spacecraft get sent into space by a growing number of countries and companies. And with that growth comes an increasing volume of leftover hardware, some of it carefully managed and safely disposed of, and some of it left to drift quietly until gravity eventually decides where it ends up. This particular story happened to end with a relatively harmless, scientifically interesting crater on an empty stretch of the lunar surface, captured in beautiful detail by a spacecraft that's been patiently doing its job for over a decade. It's a good outcome, all things considered, and one that gave scientists a small but genuine gift in the form of fresh data about impact processes and lunar geology. But it's also a reminder, a fairly vivid one, of just how much stuff we've already sent out past Earth's orbit, and how much of it we're not tracking as closely as we probably should be, especially as more and more of our attention, our missions, and our long-term ambitions turn toward the moon as a genuine, permanent extension of human activity rather than just an occasional destination for brief, historic visits. So the next time you look up at the moon, and it still looks exactly the same as it always has to the naked eye, just remember that somewhere on that ancient cratered surface, there's now a brand new hole in the ground, barely a few weeks old in a landscape that's measured its age in billions of years, a tiny but permanent reminder that even our leftovers, the things we build, use, and then forget about, eventually end up leaving their mark on other worlds, whether we plan for it or not. And if this is happening now, with the relatively modest amount of lunar traffic we currently have, it's worth genuinely wondering what the surface of the moon is going to look like decades from now, after hundreds or even thousands of additional missions have come and gone, each one leaving behind its own upper stages, its own discarded hardware, its own slow, quiet drift through the space between Earth and the moon, waiting for gravity to eventually decide where each piece finally comes to rest. Let's take a moment now to really dig into the tracking problem, because I think this is the part of the story that most people scroll right past without appreciating how genuinely strange it is. We live in an era where we can track a package being delivered to our front door down to the exact minute. We have satellites that can photograph a car parked in a driveway from orbit. And yet, a multi-hundred-kilogram piece of metal, roughly the size of a small bus, can drift through space for months, potentially years, without anyone knowing exactly where it is or precisely when and where it's going to come down. How does that happen? Well, Part of it comes down to the sheer difference in scale between tracking something in low Earth orbit versus tracking something out in the region between the Earth and the Moon. In low Earth orbit, objects are relatively close to the ground. They move in fairly predictable, well-mapped orbital paths, and there's a dense network of ground-based radar stations and optical telescopes specifically built to monitor that region, because that's where the vast majority of active, valuable satellites live. Governments and companies have poured enormous resources into building out this kind of tracking infrastructure, because a collision in low Earth orbit could take out $1 billion satellite constellation. But once an object leaves that region and starts drifting further out into what's called cislunar space, the whole picture changes. Distances become vastly larger. The object appears dimmer and harder to spot optically because it's so much farther away. Its orbital path becomes much less predictable too, because instead of being dominated by a single, relatively simple gravitational influence like Earth's, it's now being tugged on by multiple different sources of gravity at once. Earth is still pulling on it, so is the Moon. And depending on how far out the object drifts, the Sun's gravity starts to become a meaningfully complicating factor as well. This creates what physicists and orbital mechanics experts call a three-body or even a multi-body problem. And it's notoriously difficult to predict with high precision over long timeframes, especially without frequent high-quality tracking data to continuously refine the models. So an object like this Falcon upper stage, once it's released into this kind of loosely controlled trajectory, essentially becomes extremely hard to track with high confidence, unless someone is specifically dedicating resources to following it. And realistically, once a rocket stage has completed its mission and released its payload, there isn't usually a strong ongoing incentive for anyone to keep detailed tabs on it. It's done its job. It's not carrying anything valuable anymore. It's not actively transmitting data. From a purely practical, budget-driven perspective, tracking it closely for months or years afterward, just in case it happens to hit something interesting or important someday, isn't typically prioritized. That's slowly starting to change, though. And this is honestly one of the more encouraging threads within this whole story. As more missions target the Moon, and as the amount of hardware being sent through cislunar space keeps increasing, there's a growing community of researchers, both professional astronomers and dedicated amateur observers, who have started paying much closer attention to this region of space specifically. Some of the most interesting recent tracking work on drifting rocket bodies has actually come from independent researchers and small teams working with modest telescope setups, carefully analyzing orbital data, cross-referencing launch records, and essentially playing detective to figure out exactly what a given mystery object is, where it came from, and where it's likely headed. It's a great example of how this particular area of space science isn't purely the domain of massive government agencies with billion-dollar budgets. Sometimes it's individuals and small teams, piecing together publicly available data, who end up making some of the most interesting identifications and predictions. This growing attention matters because it's slowly building up a more complete picture of just how much uncontrolled hardware is actually drifting around out there in cislunar space at any given time. And the honest answer, based on what's been documented so far, is that there's probably more of it than most people would assume. Every mission that's ever sent something toward or past the Moon, going all the way back to the earliest days of the space age, has potentially left something behind out there. Whether it's a spent rocket stage, a discarded piece of hardware, or in some cases entire defunct spacecraft that simply ran out of fuel or stopped functioning and were never actively deorbited or disposed of. Now, let's shift gears a little bit and talk about the human side of this story, because I think it's easy to get so caught up in the technical details, the orbital mechanics, the crater measurements, the ejecta patterns, that we forget there's actually a pretty compelling human narrative running through all of this too. Think about the teams of engineers and scientists who work at NASA, quietly monitoring LRO's imagery day after day, year after year, sifting through an absolutely enormous volume of data covering nearly every square inch of the lunar surface. Most of the time, that work probably looks pretty routine. Compare this image to that image. Check for anomalies. Update the catalog of known surface features. It's the kind of unglamorous, methodical work that rarely makes headlines, but that forms the backbone of so much of what we actually know about the Moon today. And then, every once in a while, that routine work turns up something genuinely exciting. A brand new crater that wasn't there before. Clear evidence that something significant happened on the lunar surface recently. There's something really satisfying about that. from a scientific storytelling perspective. All that patient, methodical monitoring, day after day, eventually paying off with a genuinely interesting discovery that adds a small but real piece to our understanding of how the moon changes over time, even in the relatively short span of human observation compared to the moon's multi-billion-year history. It's also worth acknowledging the broader team behind SpaceX's operations here too, even though this particular event wasn't something they set out to do intentionally. The engineers who designed this particular Falcon upper stage, who calculated its trajectory, who made the decisions about when and how to release it after completing its primary mission, were working within the broader constraints and standard practices of the launch industry as it currently exists. This wasn't negligence in any dramatic sense. It was, essentially, standard operating procedure for a lot of missions that don't require precisely controlled disposal of their upper stages. The fact that this particular stage eventually ended up drifting into a lunar impact trajectory is more a reflection of the current state of industry-wide practices around upper stage disposal than it is a story about any specific mistake or oversight on SpaceX's part. That said, and this is worth sitting with for a moment, incidents like this one do tend to accelerate conversations within the industry about whether those standard practices need to evolve. When something like this makes headlines, even relatively modest headlines compared to some of the bigger space news stories out there, it puts a little bit of extra public and industry attention on the broader issue of space debris management, cislunar tracking, and long-term disposal planning. And that kind of attention, even if it comes from a single, relatively low-stakes accidental impact, can sometimes be exactly the kind of nudge that pushes an industry to start taking a particular issue more seriously before it becomes a much bigger problem. Let's also spend a little time talking about why the moon specifically is becoming such a focal point for this entire conversation. Because it's not an accident that so much attention is currently being paid to lunar activity. For most of the history of the space age, human activity beyond Earth's immediate orbit was relatively rare and heavily dominated by a small handful of government space agencies, primarily from the United States and the former Soviet Union, and later joined by a growing list of other national space programs. The moon itself saw a flurry of activity during the original space race era, followed by decades of relatively quiet, infrequent missions, occasionally punctuated by a notable orbiter or lander from one country or another. But over roughly the past decade, and especially in the past few years, that pattern has changed dramatically. There's been a genuine resurgence of interest in the moon, driven by a combination of scientific curiosity, national prestige, and increasingly economic and strategic considerations. Water ice discovered in permanently shadowed craters near the lunar poles has sparked enormous interest in the possibility of using the moon as a source of resources, potentially even fuel, for future deep space missions. The idea of establishing a more permanent human presence on the moon, whether through NASA's Artemis program or similar efforts from other countries, has moved from science fiction territory into genuine, funded, actively developing mission plans. This resurgence has brought with it a dramatic increase in the sheer number of missions heading toward the moon. Robotic landers, delivered both by government agencies and increasingly by private companies operating under commercial contracts, are now launching toward the lunar surface on a much more frequent basis than at almost any other point since the original Apollo era. Orbital missions designed to study the moon from above continue to accumulate as well, adding to the increasingly crowded traffic in lunar orbit itself. All of this activity means that the cislunar region, once a relatively sparse, quiet stretch of space compared to the increasingly crowded environment closer to Earth, is rapidly becoming a much busier neighborhood. And that growing traffic is exactly why events like this accidental Falcon upper stage impact carry more weight and attract more attention now than they might have a decade or two ago, when lunar activity was much more sporadic and the stakes of uncontrolled debris drifting through the region were correspondingly lower. It's genuinely fascinating to think about how quickly this shift has happened. Just a decade or so ago, a story about a random rocket stage hitting the moon might have barely registered as a minor curiosity, a small footnote in the space news cycle. Today, it fits into a much larger, much more actively discussed narrative about how humanity manages an increasingly crowded, increasingly valuable region of space that we're only just beginning to treat with the same level of seriousness and long-term planning that we've had to develop for low Earth orbit over the past several decades. Now, here's a question worth thinking about as we start wrapping this whole story up. Should we actually be worried about this? Is this the kind of thing that should genuinely concern people who care about the future of space exploration? Or is it more of an interesting curiosity that doesn't really warrant much anxiety? Honestly, the answer is probably somewhere in between. On one hand, this specific event was, in the grand scheme of things, a relatively low-stakes occurrence. Nobody was hurt. No active, valuable spacecraft was damaged. The crater that resulted is scientifically interesting rather than alarming, and it happened on an empty stretch of lunar surface with nothing nearby that could have been put at risk. In that narrow sense, there's no reason to be particularly worried about this one specific event. On the other hand, this event and others like it are useful indicators of a broader trend that probably does deserve more serious, proactive attention than it's currently getting. As lunar activity continues to increase, as more crewed missions, more permanent infrastructure, and more valuable assets get established both on the lunar surface and in lunar orbit, the acceptable margin for uncontrolled, unpredictable debris drifting through that same space is going to shrink considerably. What's a fascinating, harmless accident today could, in a busier future lunar environment, become a genuinely dangerous collision risk. The good news is that this is exactly the kind of problem that's much easier to address proactively, before it becomes a serious issue, than reactively, after something genuinely bad happens. And there does seem to be a growing awareness within the space industry, among policymakers and among the broader community of space researchers and enthusiasts, that this issue deserves more attention now. While lunar traffic is still relatively manageable, rather than waiting until the region becomes so crowded that managing uncontrolled debris becomes a much harder, more urgent problem to solve. So where does that leave us? I think the honest takeaway from this whole story is that it's simultaneously a genuinely cool, scientifically interesting event, and a useful reminder that we're entering a new phase of space exploration, where the old assumptions, the idea that space is basically infinite, and that whatever we leave behind out there doesn't really matter because there's so little else around to hit, are starting to break down, at least in the increasingly busy neighborhood around the moon. A discarded rocket stage, doing exactly what discarded rocket stages have quietly been doing for decades, drifted through space and eventually left a brand new mark on the face of the moon. NASA caught it in beautiful detail thanks to a spacecraft that's been patiently doing its job for well over a decade. Scientists got a small but genuine gift of fresh data about impact mechanics and lunar surface composition. And the broader space industry got another small but meaningful data point in an ongoing, increasingly important conversation about how we manage our own leftovers as we keep pushing further and further out into space. That's the story behind this one small crater. Not just an accident, not just a fresh hole in the lunar dirt, but a small, very real glimpse into the growing complexity and the growing responsibility that comes with humanity's ever-expanding presence beyond our home planet. And honestly, the next time NASA releases a set of images like this, showing some fresh, unexpected mark on the lunar surface, it probably won't be the last time. Given everything we've just walked through, the increasing pace of lunar missions, the amount of uncontrolled hardware already drifting through cislunar space, and the ongoing gap between how fast the industry is launching things and how carefully it's tracking and disposing of them afterward, this is very likely just the beginning of a much longer story. One crater at a time, we may be slowly writing a new chapter in the moon's 4.5 billion-year history, and this time we're the ones holding the pen, whether we meant to or not.